Yes, welcome back to the second part of application. And today we want to look at tangent and normal lines. So I want to make a drawing here so that we can use it to illustrate what we want to do. So this is x-axis and this is the y-axis. The curve, I want to draw the curve like this, and then on this curve I want to have a straight line that goes like this. So this line is my tangent, and this is the curve. This curve here is y equals to a function of x. Now I also want to have at this point where the curve touches the line touches the curve, I want to have a straight line that is perpendicular like this. Okay, and this line is what I call the normal. Now this point here, this point there, okay, I want to make it big like that, is the point I want to have a line that goes down like this. This is the point x0. It's a known point. This other one is again a known point, like this. So that point is a point y0, and therefore the coordinate for this point is the coordinate x0, comma y0, like that. So now what we have is we want the equation of the tangent. Okay, so equation of the tangent line. So we require two things. Now first we require the gradient. So how do you get the gradient of the tangent line? Now the gradient of the tangent line is the same as the derivative, of this curve with respect to x, and it is at the point x0, y0. So this one gives you the gradient. Let me call it m t is the gradient of the tangent line. What else do you require? A known point. Known point. You know, for a straight line you require two things. So the known point is a point x0, y0, because that point will always be given. You cannot get the tangent of a curve to be specific without having a known point. And therefore equation of a straight line, we all know the equation of a straight line, equation of y equals to mx plus c is given by you write y minus y0, which is a known point, and then you insert the gradient. Okay, then the other one is going to be what? X minus x0. This is how you create the equation of a straight line, any equation, any straight line. This is 3. So there are three things here. First is to get the gradient of the tangent line. And how do you get the gradient? Getting the derivative of the curve y. And how do you get the gradient? The derivative is dy over dx, and then you evaluate. You substitute x0, y0. It gives you a specific value, mt. Then for you to write the equation of a straight line, you require a known point x naught y naught, and then the way to write the equation of a straight line y mx plus c is to substitute the gradient mt and to substitute the known point x naught y naught. From there, the second thing that you want is the equation of the normal line. So for the normal line, again we require the same things. We require the gradient. Gradient is a straight line, remember, so the gradient is mn. So this implies that because the normal and the tangent are orthogonal, then we expect that the gradient of the tangent multiplied by the gradient of the normal must give us a -1. So from this equation we can be able to get mn, which is the gradient of the normal. And then we have the other things. We have a known point, which is the same point, x naught y naught. The normal passes through the same point as the tangent, which is the x naught y naught, and then we do the equation. Then we write the equation. The equation y minus y naught is equals to mn into x minus x naught. So I want to give an example here. It's a simple example. So this simple example, I want to write this. I want to write determine the equation of normal of tangent and normal lines to the equation to the curve y equals 3x squared minus 9x plus 4 at the point x equals 2. So first, the way to go about this first is to determine the gradient of the tangent. So gradient of tangent. So how do you do that? Change in y over change in x. It's the derivative of the curve. So which curve are we dealing with? The curve is y equals to 3x squared minus 9x plus 4. So what is the gradient of that? This is 6x minus 9. Now what do you want to do? To substitute x equals 2 because that is where this tangent passes through. So what does it give us? It gives us 12 minus 9, which is equals to 3. So that is the gradient of the tangent. Now point number 2 is a known point. So do we have the known point x naught y naught? Known point x naught y naught. This is what we are looking for. So the only thing that we know is that x naught is 2. What about y naught? So if we want y naught, we have to substitute x in the y. So y naught should be equals to 3, substitute 2 squared minus 9, substitute 2, then you add a 4. So what does it give us? this is equals to, this is 4 times 3, which is 12. Then we minus 18, then we add 4. What does that give us? This is a minus 6 plus 4 is a minus 2. So we already have the known point. This implies that x naught y naught is equals to 2, negative 2. Okay, now the equation of the straight line. So I want to erase this part so that we can be able to work it out. Okay, so now the equation is given by y minus y naught is equals to the gradient of the tangent x minus x naught. So this is y minus y naught. We've computed as negative 2, so it becomes a 2 plus is equals to the gradient. We computed the gradient as 3 into x minus x naught is 2. So you write 2 there, and therefore this is y equals to 3x minus 6 minus 2. So the answer is 3x minus 8. This is the equation of the tangent. This is the tangent line. Now we're interested in the normal line. So how do you get the normal line? First, we must get the gradient, mn. And how do you get that? You multiply the gradient of the tangent multiplied by the gradient of the normal. It should give us a negative 1. So I want to erase part of this so that I can have a place to write. I want to erase up to that point. Okay, so now I have mt is 3, mn bado hatujaijua, still mn is equals to negative 1. This implies that mn is equals to negative 1 over 3. The known point, we have it. X naught, y naught is the same point. So the same point is what? 2, negative 2. So now equation of normal. The equation of the normal. Y minus y naught equals m normal x minus x naught. So this is y is equals to plus 2 is equals to, this is equals to m1, mn is a third negative into x minus 2. So this becomes y is equals to a third x plus 2 over 3 minus 2. So what do we get as the answer? Is a third negative x, and then if you do 2 and minus 2, 2 over 3 minus 2 is minus 1 and a third. So minus 1 and a third is what? This is minus 1 and a third. It gives you 4 over 3 negative. So minus 4 over 3. This is our y, and this becomes the answer for the line, the normal line. This is the normal line, and this is good. So I can give you another question to attempt, but this one I want you to do it at your own free time. Now, equations don't have to be explicit, all of them. You can get an equation that is parametric in nature. You can get an equation that is implicit in nature. So the only thing that you're supposed to learn here is how to work out an equation in whichever form it may appear. So if it is in explicit, get the derivative. If it is implicit, get the derivative. If it's parametric, get the derivative. If it is logarithmic, get the derivative. Exponential, get the derivative. In whichever form the equation is going to be. So I want to squeeze in a question here for you. Okay, so I'm squeezing it in here, and I want you to get the equation of the tangent and the normal to the curve which is given down here, plus 2xy. So automatically you know that this is implicit, so you must know how to get the derivative of an implicit function. X equals 2, and the point is at point -4, comma 1. So this is what I want you to work out, and if you're able to work that one out, then you're good. Have a good day.